I'm Emiliana Simon Thomas. I'm the science director at UC Berkeley's Greater Good Science Center, and we're a partner, myself and Dacher Keltner, with the Emotional Wellbeing Network. And I'm so grateful and privileged to be here. One of my favorite things about this moment is that I've gotten to be friends with Lani Shiota for such a long time because we were both at UC Berkeley in formative moments of our academic trajectory. I consider Lani a great friend. When she comes to mind, I think of dancing. I have this idea that Lani is this somebody who brings that joy to the world, both in her own right and with some kind of dance team activity, but I'll let her tell you more about that if she chooses. So let's see, officially, Lani is an associate professor of social psychology at Arizona State University. Her studies of positive emotions, emotion regulation, and emotions in close relationships and emotional mechanisms in health behavior and behavior change use a variety of different methods, including peripheral psychophysiology, behavioral coding, cognitive tasks, and narrative analyses. She's a lead author of the textbook Emotion and co-editor of the Handbook of Positive Emotions. Her work has been published in high-impact journals, including American Psychologist, Journal of Personality and Social Psychology, and Emotion. And she's currently an associate editor at JPSB and co-editor in chief at the Journal of Affective Science. And another wonderful thing about Lani, which you would really appreciate if you were trying to navigate San Francisco or really most of the Bay Area, is that apparently her superpower is awe-inspiring parking karma. What that means, I think, is that if you're with her in the car and you try to manifest a parking place, it occurs. So Lani, I can't wait to take a car ride with you. And with no further ado, let's invite Lani to share her screen and tell us all about positive emotions and psychophysiology. And don't forget to unmute, Lani.
All right, can everybody hear me okay? And see the screen all right? Wonderful. Thanks so much for that kind introduction, Emiliana. I consider you a friend too, and it's been lovely working together over the years. Thanks to the whole network for the invitation to speak today. I've already learned a lot, and actually, as you'll see as I went through the talk, I was surprised by a couple of things, even in preparing my own talk. Data that I thought should be there and suddenly realized weren't, that I know of. And so it's actually raised some exciting questions for me about future research. My aim in this talk today is to build on Julian's terrific introduction to the general topic of the relationship between autonomic nervous system influence on the body and well-being. In his case, he focused on vagal parasympathetic influence on the heart, right, as measured by heart rate variability or respiratory sinus arrhythmia, kind of two measures of essentially the same thing. And I'm gonna grow on that in a way that sort of expands the range of both measures that we look at and how we think about these problems, and then pass the ball to Wendy, who's gonna build on that even further. So that's my aim for today. In terms of a quick overview of the talk itself, I'll start by simply asking, what is the role of positive emotions in well-being? And then move from there into, well, what do we know about autonomic nervous system mediated physiological changes and how those relate to positive emotions, and how this reactivity relates to well-being? And then really wrap up with, what is the research that we need, to connect the dots between positive emotions, autonomic nervous system manifestations, and well-being and health. And that is where I'm going to suggest that there's actually a very, very large gap that needs to be filled. Now, I'm going to approach this from a somewhat different stance than Julian did. Julian's talk gave us an absolutely lovely and rich overview of the relationship between heart rate variability, so vagal parasympathetic influence on the heart, as a baseline characteristic, right, at the trait level of analysis. So folks who are characterized by relatively high resting heart rate variability show all of these terrific characteristics with respect to self-regulation, affective outcomes, cognitive outcomes, health-related outcomes. And Julian talked about the pathway by which we could expect that those might occur. I'm going to be focusing more at the state level of emotional experience. And a big part of my message is going to be that sometimes there are different things going on, right? And what we're looking for in terms of physiology is going to vary depending upon whether we're looking at relatively dispositional characteristics, rather what's going on in the moment, and also what we even mean by well-being. So let's go ahead and get started with that. So what is the role of positive emotions in well-being? Before even digging into the physiology, I think it's useful to talk about this. The definition of well-being typically includes a lot of different stuff, right? There are lots of different definitions of well-being out there. And as was discussed earlier today in the introduction, one of the first steps of the broader NIH-supported network on well-being was to try to make some sense of all of this. But it really comes down to a few different domains. We can talk about life satisfaction. So when you evaluate your life in a relatively detached and cognitive way, are you saying, you know what, my life is pretty darn good? There's also eudaimonic well-being, which has a lot of different facets to it, but generally comes down to, do I feel like my life is meaningful and full of purpose, right? What I'm going to focus primarily on today is what's called hedonic well-being, which is defined by, typically, in terms of the way that we measure it, two components. So one is relatively infrequent and low intensity negative emotional experience or negative affect. And the other is relatively high positive affect. And in my own talk, I'm going to focus on the last of these, right? What is the role of positive and affect and emotion in well-being? How does it relate to the others? And how does it relate to what's going on in our body during emotional experience? Now, this raises some really interesting questions. We can think of a lot of different ways to feel positive, right? Lots of different versions of positive emotion. And I'm going to kind of speed through this, but I'll ask you to ask yourself, would you consider this state to be a pleasant state that is indicative of well-being? Well, it's probably the canonical one that we think of at this point in the research, right? That is sort of the uber image of well-being right there. What about this one? Not super controversial, probably pretty good. This one also, savoring a pleasant moment. Yeah, well-being sounds good. These ones, what's different about these ones is that they're clearly indicative of well-being, but unlike the first three that we looked at, these are not inherently calm states. They're actually highly activated states. And that activation is experienced as pleasant. So that should start raising some questions right now. And then we get even more complicated than that. What about this one? You know, I can envision a range of responses from, yeah, that's totally well-being, to, hold on a second, that's not well-being, that's not healthy. And it does become more complicated, and we start to consider the possibility of a quadratic relationship, right? If you've got too much of that going on, if that appetitive positive affect is dominating your experience, there can be some negative consequences. We're starting to think about addiction, right? If there's none of it, that's also not good. Now we're starting to talk about something that looks like a lack of reward orientation to the environment and depression, right? So it gets more complicated. What about this one, right? Well, if we can detach a minute from the way that it's being displayed and say, what about the affect that underlies that? Is that a valuable and important part of well-being, even though we might look at that picture and go, right? So this is kind of the territory that I want to take us into a bit with the talk today. So when we ask the question, what is the relationship between positive emotion and well-being, I actually went back to some data that I had. This particular analysis is not published, but I went back to a data set with over 200 community living adults from the Bay Area in their 20s, 40s, and 60s. This is a study done more than a decade ago with Bob Levinson. And we just happened to have measures of an instrument called the Dispositional Positive Emotion Scale that I actually developed as part of my dissertation working with Dr. Keltner. that differentiates between the trait level experience or the dispositional experience of several different positive emotions. And I'll just go ahead and let you read through these. These words pretty much stand for what they sound like they should stand for. I will simply mention that joy in this measure is activated. It's closer to appetitive enthusiasm rather than a calm joy. So it's a more activated state. And that love in this case very much has an attachment focus to it. So it's more of an attachment love, flavor of love. But we have this questionnaire measure that differentiates among these 6 subscales, and as well as a number of measures that are commonly considered measures of well-being. So I just asked, if you enter all of these into a simultaneous regression predicting each of the measures of well-being, what do you get? Well, this is a set of positive relationships. And by positive, I mean that the association reflects a positive association between frequency and intensity of the positive emotion that's in the columns with the particular index of well-being on the right in a way that suggests higher well-being. That doesn't always mean it's a positive association, right? So a negative association with negative affect or depression is still indicative of this positive emotion is associated with generally better well-being profiles. And what's a little bit striking here is that while there are some similarities, right, contentment and pride actually carry a great deal of the variability here. There's also some differences. So if you look at the PANAS positive activation scale, you see that it's actually joy that's associated with it, and contentment is negatively associated with that particular metric. And that's probably because the PANAS positive activation scale focuses on high arousal positive affect. It actually there are no items on that measure that involve low arousal positive affect or even social positive affect, such as love. And notably, there are some negative associations as well. And again, by negative here, it doesn't always mean literally negative. It means that higher rate or higher dispositional tendency toward that particular positive emotion is associated with worse well-being on at least one metric. So these are some of those examples. So compassion is a little bit of a mixed bag, right? On one hand, it can be pleasurable to be concerned about another, and ideally that's the form that it takes, but it also involves empathizing with another's pain or distress. And we see a little bit of that there's a compromise in there. And then interestingly, higher experience of dispositional experience of joy, that more high arousal positive emotion is significantly associated with higher experience of negative affect. And I'm going to kind of come back to the implications of that a bit later in the talk. Well, given that we're talking about some of these different positive emotion states, what autonomically mediated physiological changes are associated with these states? So in a relatively early study in my career, it was actually intended as a pilot study, and the results were so strong that we went ahead and published this. And I'll come back to the limitations of the study in a little bit. We brought folks into the lab and had them do a series of trials in which they looked at a 60-second, just an X on the screen baseline, and then we showed them 6 images for a total of 90 seconds, geared toward eliciting a particular state. I'm going to focus on the positive emotions today, but we did have some negative emotions in the study as well, and I'll refer to one of them in particular. Now, these are examples of the slides that we used. Everything that I'm going to show you today is relative to physiological responses to a neutral control stimulus, because anytime you show people a visual image, they have a physiological response to that. It's called the orienting response. And I'm going to come back to that later too. It's, oh, this is a new thing, I'd better pay attention, right? And I may need to do something about this. So you want to control for the fact that people are just looking at a thing that's new that's appeared on the screen. But we also showed people a series of slides that tapped something we call appetitive enthusiasm. This is basically a lottery. So at the beginning of the trial, we said, you have a lottery ticket with these 5 numbers that you can see at the top here. And we're going to start pulling balls, right? And the number of matches between the balls that we pull and your lottery numbers is going to determine the amount of extra money you win today. And participants coming into the study had no idea this was going to happen. And over the next 5 slides, they see these balls come up that, as it turns out, perfectly match their own numbers. So they're going to get $10 that they weren't expecting coming in. And they're kind of waiting to see what the next ball is going to be. We also used images of pilot tested childhood figures like Big Bird and Winnie the Pooh to tap into something that kind of felt like attachment love without the need to get individual attachment figures for each participant. We had a whole bunch of baby animals to pick up on what we call nurturant love, which is not quite compassion. It's more of an emotional response to cuteness, that feeling that you get when you encounter something that is young, vulnerable, and in need of care. We had awe stimuli as well as Far Side cartoons aimed at eliciting amusement. So the question is, how did people respond physiologically to these? We had several measures of physiology that we used because we were interested in the profile across these, not necessarily focusing on one particular measure, although we did ultimately look at effects one measure at a time. Now, some of these are going to be pretty familiar. Heart rate and respiration rate are pretty much what they sound like, right? Number of heartbeats per minute, number of breaths per minute. And as Julian noted in his talk earlier, those are kind of weird measures because any change in them could be explained in terms of a change in sympathetic nervous system influence or a change in parasympathetic nervous system. We call that dual innervation. And as a general rule, increased sympathetic influence on the heart and the lungs speeds up that rate, and increased parasympathetic influence slows that rate down. Pretty straightforward though. Julian told us a lot about heart rate variability, and the particular measure that we used in this study was respiratory sinus arrhythmia. It's that change in heart rate that you see when you're breathing. We also measured mean arterial pressure, which is pretty much what it sounds like. It's your average blood pressure, right, over time during a particular period of time. And that is, there are multiple influence, but it's largely influenced by a branch of the sympathetic nervous system in this context. I'm going to talk a little bit more because I know there's a range of experience here with some of the measures that we're talking about these two, cardiac pre-ejection period and the number of skin conductance responses, because they turn out to play a pretty interesting role in the story. And I want to make sure that these measures are familiar to those of you who are here today. So let's start with pre-ejection period. How do we go about catching this? So the red line on the top of this graph probably looks pretty familiar. That's an electrocardiogram, right? So it's when you stick a couple sensors measuring electrical activity on 2 sides of the body, hopefully with a ground someplace, you don't get shocked, and measure the electrical charge that's generated by the heart as it's in the process of contracting. And the red line at the top is the pretty standard ECG, EKG, depends on how you spell cardio, right? That we see when you take that measure. What's on the bottom, the blue line below that, is a measure of what's called impedance cardiography. It's the impedance signal that you get when you put a couple sensors on the front of the chest, a couple sensors on the back of the chest, and this sounds creepy, but it's fine, pass an electrical signal across the chest wall. And you wait and see how long it takes to get from the front to the back, right, to cross the chest wall. And what happens with that signal is that it speeds up when blood is expelled through the heart, when the aortic valve pops open during the process of the heart contracting. The aortic valve pops open, blood shoots out the aorta, and this signal ramps up, right? And you can see that in this blue line suddenly going up, right? As the speed of that signal changes. So what we're going to be doing with cardiac pre-ejection period is looking at the relationship of these two signals to each other. So in the image that's here, I've blown up those two signals to focus on a single heartbeat. And what a lot of processing programs do is they say, okay, you're looking at this 15-second time window. They actually average the signals across beats to clean them up and say, in general, here's a typical EKG beat, and that's the red line that's now below, and a typical impedance signal that accompanies that beat, right? And that's the white line above. So there are a couple points that we're looking for. If you look at the yellow circle on the lower EKG trace, that's the red one, you see this little notch, and I don't know if you can see it, but there's a little Q underneath that. That Q point indicates electrically the onset of the heart contraction. So it's just beginning. If you then look above that, you're going to see another little yellow circle on the white line, and there's the letter B next to it. That point B and the little notch there basically indicates that the aortic valve has popped open, and that sudden increase that you see in that white line is blood shooting through the aorta. Cardiac pre-ejection period is the time that's elapsed, it's measured in milliseconds, between Q and B. So it's the time between when the heart begins, the left ventricle specifically begins to contract, and when the aortic valve pops open. Enough force has built up to pop that aortic valve open and shoot blood out the aorta. And you can imagine, if my hand is a heart, right, you can imagine that if it's doing this, that period is relatively long. It's relatively slow contraction. And imagine if this was a water balloon, the level of force of the blood coming out of it. Now imagine that the heart's doing this. The speed of that contraction is a lot faster. And imagine if this again was a water balloon, what the implications would be for the blood shooting out. Why is this a useful measure, and why is it becoming increasingly relied upon in research on emotional responding? It's because, unlike heart rate, it is only influenced by the sympathetic branch of the autonomic nervous system, and by a pretty specific mechanism at that. So it's activated through beta adrenergic receptors on the heart. So it's a way of kind of fine-tuning the autonomic mechanism of the effect that we're seeing. So that is one important measure. It's an important index of sympathetic, relatively pure sympathetic index on the heart. The other one I'm going to talk about, you might have heard of before, it is the skin conductance response. And this one's actually fairly straightforward. Kind of what it comes down to, relevant to the last measure as well, is that the human body does a really nice job of conducting electricity, and we take advantage of that in these measures. In this case, what we're picking up on is not a change in cardiac activity or blood flow. We're actually looking at the influence of the sympathetic fight-flight nervous system via cholinergic receptors on sweat glands. So one effect, if you've ever noticed when you are stressed or anxious, one common response is that you start sweating, right? Well, that is basically saturating the skin with salt water. And if we've got sensors, right, electrical sensors on two fingers, you can actually put them a lot of different places, but the hands are common because they pick up that sweat activity pretty quickly. And then again, you pass a signal through one and see how long it takes to get to the other one. The speed of that is indicative of the amount of sweat that has just occurred. And we can pick up these remarkably minute little bursts of sweat gland activity, which again is indicative of increased sympathetic activation. Now, what might jump out at you is that whereas in Julian's talk, he focused on the parasympathetic major branch of the autonomic nervous system, I've just spent a bunch of time talking about the sympathetic branch. And now hold on a second. Isn't that the fight-flight branch? Isn't that the branch that's activated when we're in danger or facing a threat and we need to fight or run away? It's really easy, as you're getting to know this literature and digging into it, to come away with an anticipation, not a message that is sent certainly by Julian, and not a message that is sent by folks who really have expertise in this literature, but if you're just reading the body of work on how the autonomic nervous system relates to emotion and well-being, it's very easy to come away with the impression, right, that fight-flight arousal is bad, and we want to avoid that and minimize it. And parasympathetic tendon befriend or rest and digest activation is good, and we want as much of that as possible. There are certainly some truth to that, but what I'm going to talk about today is some caveats as well. So let's take a look at what happened to people when we showed them these slides. In the enthusiasm slides, those lottery slides, we saw a profile of responses that suggests both widespread sympathetic nervous system activation and a decrease in parasympathetic activation, right? So I told you that we also had negative emotion trials, a trial in this as well. And what was really funny in looking at these data is this is indistinguishable from fear in our data. Now, I think Wendy might talk a little bit more about the distinction between threat and challenge later on, and some of you may be familiar with that distinction as well. I think it's highly likely that this looks a little bit more like challenge than like threat. But the crucial thing for our purposes right now is that it's a highly activated and aroused state. And at least some of these effects are mediated by sympathetic nervous system activation. In the two love conditions, we saw an increase in arousal. So, and again, this is all relative to what happens to people's bodies when they're watching those neutral slides as a control. We saw a relative increase in heart rate and for nurturant lover respiration rate, and a reduction in RSA that was significant. So reduction in heart rate variability. Looking at the total profile, this actually suggests a withdrawal in parasympathetic nervous system influence. And as Julian mentioned earlier, simply withdrawing parasympathetic influence can actually be a rapid and responsive way to increase activation in the body without having to get the sympathetic nervous system involved at all. Amusement didn't show a whole lot of change. Honestly, I think our slides just weren't that funny for this cohort. They said they were funny, but they weren't cracking up or anything. But other studies using other stimuli have shown a widespread increase in sympathetic nervous system influence and the signs thereof. Awe got really interesting because this is the one that was not activating at all. We saw an increase in respiration rate, a significant and fairly noticeable increase in the length of cardiac pre-ejection period, as well as a decrease in respiratory sinus arrhythmia. And what this suggests is a sudden decrease in both sympathetic and parasympathetic influence on the heart. Now, the first time I presented these data at the conference, I went, I've never seen anything like this in emotion before. I'm not entirely sure what to make of it. And a colleague came up afterwards and said, well, you know, the other time when you see that, I said, no, she said, after orgasm. It's a colleague who studies the sexual response, says immediately preceding orgasm, you have a period of time when both sympathetic and parasympathetic innervation and activation are quite high in this highly activated but regulated state. And afterwards, they both come down, and something similar seems to be happening with awe. Now, the key message here is that these different positive emotions seem to have different physiological profiles. So there's no single physiological marker of positive emotion as a state, which is distinct from correlates of trait experience of positive emotion, which do include heightened resting RSA or heart rate variability. So what do we do with this? Well, for one thing, this is one study. It's a small study. It's a study with a variety of limitations, totally acknowledge that, but it's helpful to look across the broader literature. And when you do that, you continue to see the message that several positive emotion states are actually best characterized by physiological arousal. And that probably affects appetitive or approach motivation, right? Preparation to act, to move toward whatever stimulus or opportunity has evoked that state. And that positive emotion is mediated by some combination of an increase in fight, flight, sympathetic influence and a reduction in vaguely mediated parasympathetic influence on the heart. And that's just the measures that I talked about. There's all kinds of other measures that we could be looking for as well. But these messages are pretty clear. Having said that, there are other positive emotions that are better characterized by physiological soothing and calming. And this typically reflects an increase in parasympathetic influence. Again, the vagal influence on the heart is the version of that that's most typically measured, and or hormonal influence and oxytocin, especially when we start talking about the experience of positive emotion in close relationship and intimate relationship contexts. Oxytocin may play an important, and other hormones may play an important role in that as well. What really stands out when you look at this literature, and I'm basing this on a meta-analysis by Maciek Benke and colleagues that just came out this year, is that although a few positive emotion states, including appetitive enthusiasm, and amusement, have received a great deal of study, most positive emotion states have received very little study, and most of the research has just focused on heart rate, right? Maybe skin conductance, the measures that are not all necessarily that informative. And some positive emotion states, including contentment and pride, the ones that were most closely linked to well-being in the data that I showed earlier, have received little or no study at all. So there's actually a lot of work that needs to be done to better characterize this space, and that's one key message. The other key message that comes out is that, as you may have noticed, that whereas Julian just gave a lovely talk linking relatively trait level or dispositional vagal influence on the heart, right, as indexed by heart rate variability, with positive emotionality, with aspects of well-being, with self-regulation, we actually saw the opposite effect during experimentally evoked state experiences of most positive emotions. So we got to be really careful in assuming that associations we see at the trait level will show up at the state level as well, and vice versa, because the mechanisms may be completely different, accounting for those associations. So general principle, baseline correlations of physiological activity with trait positive emotion or trait well-being may actually differ from or even oppose the direction of association that you see at the state level in tasks that evoke emotional states. Okay. Let's move on to the next question, which is, how does physiological reactivity to positive emotion stimuli relate to well-being? I have to say, this is where I looked at my own data and went, I actually don't have very much that gets at this, which is just weird, right? But when I looked at the data sets that I have, some of which are quite large, I was surprised to see that as a general rule, the studies where I was experimentally activating positive emotion and measuring physiological response, absent a stress task, right? Not as a response to stress, which Anthony, I think, is going to talk about later, right? The undoing effect, but just how does your body respond when you look at a potential opportunity or reward? I didn't have measures, and vice versa. The studies where there were good well-being measures, there's a big gap in the literature right there that really got me thinking. But I did have one study, and I'm being mindful of time here. Do I have 5 more minutes?
Yes, go ahead.
Okay, I'll jam. I did have one study that actually sort of hinted in that direction, and it's actually using the same data set that I just presented. This is a secondary analysis of it that was conducted by my grad student, Claire Yee, who was particularly interested in adult attachment. She helped collect those data, and she requested that a measure of adult attachment style be added to it. So most of you are probably familiar with adult attachment. You know, we're talking about a profile of relatedness to another individual who is an attachment figure. It's characterized by proximity seeking. We want to be close to them. We don't like being separated. Safe haven, we turn to them in times of distress. And the secure base phenomenon, which tends to get left out of these conversations, right? The idea that because this person is in my life and providing a sense of security, I can take risks, I can pursue opportunities, I can go big, right, safely, because I know this person's got my back, right? And so that's actually the part I'm going to focus on today. Claire was interested in looking at adult attachment style. These are our mental models of what we can expect from close others. And it shows up in the emotions that we experience and behavior in the context of intimate relationships. When we talk about attachment security, this is the general expectation that our close others are going to be accessible, responsive to us, right? So they're there for us when we need them. From an operational standpoint, we typically measure attachment style in terms of deficits in security, 2 different kinds of deficits. One is attachment anxiety. So this is the experience of intense need for intimacy, but combined with strong fear of abandonment. We're scared they're not going to be there, although we desperately need them. The other is attachment avoidance. And it's unclear whether the system is actually just turned off or it's being damped down all the time, right? But when people talk about their attachment needs, what they report is they're just uncomfortable with this whole attachment thing. They don't like depending on other people. They're not trusting, and they are not comfortable with commitment. So Claire wanted to look at the extent to which attachment anxiety and attachment avoidance were associated with how people responded to those same slides that I showed you earlier. And her theoretical focus here was on secure base, right? Do attachment anxiety and avoidance predict people's responsiveness, physiological responsiveness to a potential reward when they see one? And can we pick that up in this study? The measures that we use are measures of physiological orienting, right? So remember how I said in all of this work, we have to use a neutral control task because people respond physiologically to that too. That orienting response consists of two components. One is the heart rate for like a second slows down. And that appears to track attentional engagement. Are you paying attention to the stimulus? The other is a brief burst of sweat gland activity that's thought to track preparation for action. That second one is definitely mediated by increased sympathetic fight-flight influence on your sweat glands. This is probably an index of getting you ready to move and do something about this opportunity that's in front of you. Go engage with it. Go work with it. What we found is that there was no consistent multivariate relationship between the cardiac deceleration measure and any of our responses to these positive emotions slides, right? And this suggests that attentional orienting to rewards was largely unaffected by the lack of secure base, as people reported in through anxiety and avoidance. The exception was the lottery slides, which I thought was funny. I think what may have been happening there is that folks who were either high on attachment anxiety or avoidance may not have believed we were going to give them payment. They just kind of checked out of this whole situation. But that was the only effect that we saw. When you look at skin conductance, though, and remember, this is thought to be an index of the approach orientation component of the orienting response, we did see a multivariate main effect of avoidance. So in general, across these slides, we saw that people who reported being more attachment avoidant showed lower skin conductance responses. It's like they saw the slides, right? But weren't really inclined to do anything about it. So one possible interpretation of this is that that lack of a secure base that particularly characterizes attachment avoidant folks may actually be interfering with their ability to go in a positive way or sort of automatically think about approaching not only social rewards, but material and aesthetic rewards as well when they're presented in the environment. It's a very subtle effect. Again, it's a fairly small study, but it's kind of a hint that once we start compromising people's reactivity to positive stimuli, there may actually be consequences of that for well-being that are important. What new research linking positive emotions, well-being, and health is needed next? Well, I think we need more research linking positive emotions, well-being, and health that focus specifically on positive emotion reactivity in the physiological domain. There's a great deal of research linking positive emotions, well-being, and health, broadly speaking. I do not mean to undermine that. It's terrific work. But on the whole, it actually hasn't focused on or measured autonomically mediated responses. And I think that's actually quite an important gap to fill as we start to think about what well-being might look like over time in the body. And I think Wendy's going to pick up from there. I will close by asking you, does this look like well-being? Does it look like positive emotion? Not if you think yes. What if I tell you that before this picture, about an hour before this picture was taken, I found out that a very close friend from college was dying. She was literally in hospice at that moment, and we were waiting. And I chose to go to this beautiful space with some friends it's actually outside Vegas, of all places to be at that time, and engage with this beautiful setting. Is that well-being? I would say that yes, it is. But if we're going to start talking about physiological markers of well-being, we need to be ready to deal with that level of complexity and acknowledge that emotional well-being is not defined by a single state. It's probably defined by context-appropriate emotional experience that engages in a healthy way with what's going on in the environment around us. So to really quickly sum up, High dispositional positive affect or activation or emotionality is commonly considered a defining feature of well-being. But multiple positive emotion states do exist, and these vary in terms of what they look like in the body and how they relate to the other aspects of well-being. Although at the resting level, vagal influence is highly predictive of well-being, positive emotion states often involve heightened sympathetic influence and in some cases reduced parasympathetic influence. And we can't assume that the relationships between physiological activity, autonomically mediated physiological activity, and well-being are going to look the same when we're looking at dispositional characteristics versus state reactivity. We definitely need more rigorous research to characterize autonomically mediated reactivity during positive emotions, especially for the ones that have received left study, and to link that to well-being. And to pass the ball to Wendy, a key point here is that the physiological markers of well-being, especially at the state level, are going to be those that facilitate context-appropriate motivational responses to our current situation, in this case, distinct kinds of adaptive opportunities. That is not intended to in any way undercut what Julian said. He actually sent a very similar message and emphasized the role of the parasympathetic and vagal branch in doing exactly this and being able to respond quickly to what's going on in the environment. That's a message that needs to continue to grow outward. So with that, I'll end, and hopefully we still have a little bit of time for questions.
Bravo. Thank you, Lani. That was an amazing compliment to Julian's opening session. And it's just so rich to reflect on these kind of temporal dynamics, the difference between thinking about emotional well-being in a broad kind of global way, or thinking about the componential processes or the momentary experiences and behaviors that sort of contribute to the possibility of a person arriving at that more global quality of emotional well-being. We're a little bit behind, but let's just do one question. And what our next activity is essentially a break. So if people want to stick around and listen or participate in discussion, please do. But if you need to go grab a snack or stretch or be outdoors for a few minutes, that's all right also. Lani, I want to know, or there's a question about attachment and positive emotion and the last several years that we have undergone. Do you think that there's some interesting findings about people's experience or eligibility to feel positive states or their attachment status in relationship to COVID?
Yeah. Oh, we've been through so much. Yeah. I have some data that I decided not to share just because it didn't involve physiology and had to make some choices. As you see, it was a pretty packed talk. You know, I think one thing that really jumps out in looking at the well-being field and in thinking about how we've approached physiological responses that characterize well-being is how much we've been focusing on the absence of the negative. How much of that work, what we call, how we operationalize well-being, often comes down to how well do you handle stress? How resilient are you? Are you low on anxiety and depression? We're not doing as good a job at measuring the presence of positive well-being. And I think we need to get a lot better at that. We need to get a lot better at it theoretically, operationally, and in terms of how we think about what that's going to look like in the body and what we're going to promote and what mechanisms might lead from there to physical health. We're not doing a fabulous job with that. And I think a lot of that comes down to the sort of the primacy of negativity, which is a real thing, right? Except when we take it too far in the research. What really leaps out in the conversation, the scientific conversation around the pandemic in the last few years is, again, the emphasis on stress regulation. that somehow the primary thing that we need to do is alleviate the stress. I've done that, right? And I think we've put a lot of those in place, and we're still languishing. We still don't feel right. We still don't feel well. We just feel okay. I'm at, music fans out there, if you've heard Numb Little Bug, right? That song, not really happy, but I don't want to die, right? And I just keep putting Band-Aids on my well-being. That's not a state of thriving. It's not a state that we want to be in. And so I think we need some more techniques, not only for regulating stress, but for increasing the joy in our lives. And savoring is one of those techniques that I think needs some additional research. Thanks to Dacker and colleagues, there's a very young but growing body of research on how we can use daily awe experiences to increase our thriving. I think we need to take more seriously the idea that positive activation is a really important part of psychological well-being. And so those are some directions that I think we need to go in, because we can alleviate stress all we want. That doesn't make us well. And as we emerge from the pandemic, finding that joy again, finding that spark of engagement with life is going to be absolutely crucial to really healing.